Have you ever wondered what lies beyond the four dimensions we perceive in our daily lives? Welcome to an exploration into the enigma of the quantum realm, a world that defies the very laws of the universe as we know it. Quantum physics, the study of the very small, the subatomic level, is not just a branch of physics. It's a realm of reality that transcends our conventional understanding. It's a world where particles can exist in two places at once, where time can move both forwards and backwards, where reality itself is not as concrete as it seems. But what if I told you that there could be more, a fifth dimension perhaps, lurking beyond the four we perceive, length, width, height, and time, a dimension that could hold the answers to the mysteries of the universe, where the laws of physics may be even stranger than we can imagine. The concept of a fifth dimension isn't just science fiction, it's an idea that has been seriously considered by some of the greatest minds in physics. While we can't perceive this dimension in our daily lives, it could be integral to the very fabric of reality, influencing the behavior of particles in ways we are just beginning to understand. Quantum mechanics, the theory that governs this realm, is as perplexing as it is fascinating. It challenges our conventional logic, forcing us to question our understanding of reality. It's a world where the impossible becomes possible, where the line between reality and fantasy blurs. But as we venture further into the quantum realm, we must be prepared to leave our preconceived notions at the door. For in this world, nothing is as it seems. The quantum realm is a labyrinth of mysteries, each turn revealing a new enigma, each step leading us deeper into the unknown. So hold on to your seats, because we are about to embark on a journey into the uncharted territories of the quantum realm. As we delve deeper, prepare to have your understanding of reality turned upside down. Imagine a cat that is both alive and dead until you look at it. This idea might sound bizarre, but it's an essential part of quantum mechanics known as superposition. It's the concept that particles can exist in multiple states at once, only settling into one when observed. Think of it like flipping a coin. Until it lands, it's both heads and tails. Now let's apply this to Schrödinger's cat, a thought experiment proposed by physicist Erwin Schrödinger. He imagined a cat inside a box with a radioactive substance that has a 50-50 chance of killing the cat. Until we open the box, according to quantum mechanics, the cat is both alive and dead. This principle challenges our everyday experiences of reality. We're used to things being one way or another, not both at the same time. But in the quantum realm, the rules are different. So, is the cat alive or dead? The answer might not be as simple as you think. What if I told you that two particles can be intimately connected, no matter the distance between them? This isn't a plot from a science fiction novel, but a genuine phenomenon in the strange world of quantum mechanics, known as quantum entanglement. Quantum entanglement is a peculiar occurrence where pairs or groups of particles become intertwined in such a way that the state of one particle is directly tied to the state of the other, no matter how far apart they are. This means that if you measure one particle and change its state, the state of the other particle will instantaneously change too. It's as if these particles are communicating faster than the speed of light, something that contradicts Einstein's theory of relativity. This phenomenon was so perplexing that it even baffled Albert Einstein himself, who famously referred to it as spooky action at a distance. Einstein, along with Boris Podolsky and Nathan Rosen, proposed a thought experiment in 1935 to challenge quantum mechanics, known as the EPR paradox. They argued that quantum mechanics must be incomplete because it does not account for certain hidden variables. However, the subsequent experiments have shown that these hidden variables do not exist, and quantum entanglement does happen. The implications of this are staggering. Imagine, for instance, two entangled particles light years apart. A change in one particle would mean an instantaneous change in the other particle, no matter the distance. This could revolutionize communication, computing, and even our understanding of the fabric of reality itself. However, quantum entanglement is not as easily exploitable as it might seem. It's a delicate state that can be easily disrupted, and harnessing it for practical applications remains a significant challenge for scientists. Nevertheless, the promise it holds is truly fascinating and is driving research in the field of quantum information. The world of quantum mechanics is strange and counterintuitive, challenging our understanding of the universe. This is especially true for quantum entanglement, a phenomenon that seems to defy our everyday logic and even the fundamental laws of physics. But remember, in the quantum realm, things can be much closer than they appear. Can we ever know both the speed and location of a subatomic particle? This question leads us to Heisenberg's uncertainty principle, a cornerstone of quantum mechanics that presents a peculiar paradox. Imagine trying to pin down a particle only to find that the more precisely you measure its position, the less certain you become about its speed, and vice versa. The uncertainty principle tells us that the act of observing alters the observed, making precision a game of trade-offs in the quantum world. This isn't due to any limitations in our instruments. No, it's an inherent aspect of nature itself. It's as if the universe is saying, wait a minute, you can't have it all. What does this mean for predictability? It paints a picture of a quantum world that is fundamentally unpredictable. Our classical notions of cause and effect begin to blur, replaced by a cloud of probabilities. In the quantum realm, certainty is a luxury we cannot afford. Have you ever dreamed of walking through walls? In the world of quantum mechanics, this isn't just a far-fetched fantasy. It's a reality thanks to a phenomenon known as quantum tunneling. Now, let's take a moment to wrap our heads around this. Picture, if you will, a ball. Under normal circumstances, if you roll this ball up a hill and it doesn't have enough energy to make it over the top, it will roll back down, right? That's the classical physics we're all familiar with. However, in the quantum world, things are a bit different. That ball, or rather, a particle, can sometimes make it to the other side of the hill, even if it doesn't have the necessary energy to do so. This is quantum tunneling. But how? You might ask. The answer lies in the inherent uncertainty of quantum particles. You see, a quantum particle doesn't exist in one specific place. Instead, it exists in a haze of probability, a cloud of maybe here, maybe there. It's the spread of probabilities that allows a particle to tunnel through barriers that should, by all classical accounts, be impassable. Now here's the kicker. Quantum tunneling isn't just theoretical. It's happening right now inside you. It's the mechanism that powers the sun and the stars. As particles tunnel their way into atomic nuclei to fuel nuclear fusion, it's also at the heart of many modern technologies, from tunnel diodes to scanning tunneling microscopes. So, can we humans use quantum tunneling to walk through walls? Well, the laws of quantum mechanics don't forbid it. But before you go running into the nearest wall, remember that the probabilities are extraordinarily tiny. So small, in fact, that you'd have to wait longer than the age of the universe for it to likely happen. But hey, never say never. In the quantum realm, even walls are no barriers. So the next time you find yourself up against a wall, whether literal or metaphorical, remember, in the world of quantum mechanics, impossibilities are just probabilities waiting to be realized. Scene script. Are you ready to step into the fifth dimension? Our journey into the quantum realm has brought us to the precipice of understanding, a place where the conventional laws of physics seem to lose their footing. We find ourselves staring into the abyss of higher dimensions, realms beyond the three spatial dimensions and the fourth dimension of time that we are accustomed to. The concept of a fifth dimension is not born of science fiction, but rather the product of advanced theoretical physics. String theory, a leading candidate for a unified theory of everything, proposes the existence of up to 10 dimensions. These extra dimensions, although imperceptible to us, could explain some of the most profound mysteries of our universe. Imagine, if you will, a sheet of paper. To a two-dimensional being living on this sheet, the concept of up or down would be inconceivable. But we as three-dimensional beings can easily move up or down, transcending the flat world of the paper. Similarly, entities in a fifth dimension could have access to a reality entirely outside our comprehension, just as we can step off the sheet of paper. It's tantalizing to think of what lies beyond our perceptual reality. Could parallel universes exist in these higher dimensions? Could there be realms where time runs backward or the laws of physics are entirely different? While these ideas may sound fantastical, they are not beyond the realm of possibility according to our current understanding of quantum mechanics. The exploration of higher dimensions is like venturing into a dark forest where every step reveals new, uncharted territory. It challenges our preconceived notions of reality and pushes the boundaries of our understanding. But that's the beauty of science, isn't it? It's a constant quest for knowledge, a journey that takes us beyond the familiar and into the unknown. As we stand on the brink of the fifth dimension, we realize that the quantum realm still holds many mysteries waiting to be uncovered.